Variable resistors. In many circuits, it is useful to be able to change the resistance. For example, in a dimmer switch for a lamp, or in the volume control of a music player. The component that is used to change resistance is called a variable resistor.
The circuit symbol for a variable resistor is similar to that for a fixed resistor, but with an arrow through the symbol, like this. The term fixed resistor is sometimes used for the type of resistors you learnt about in Topic 9.3, to avoid confusion with variable resistors. This diagram shows how a variable resistor is used to control the brightness of a lamp. As the resistance of the variable resistor is increased, the current in the circuit decreases. A smaller current flowing through the lamp makes the lamp dimmer. As the resistance of the variable resistor is decreased, the current in the circuit increases. A larger current flowing through the lamp makes the lamp brighter. Electric circuits are used in many homes, schools, cars, bicycles, phones, music systems, watches, computers, and lots more things that we use every day. Scientists are always designing new circuits, many of which make life easier for us. Here, we will look at some examples. When opening the door of a refrigerator, fridge, a light comes on inside. The circuit for this is shown in the diagram. The switch is opened and closed by the movement of the fridge door. When the door is open, the switch is closed, and when the door is closed, the switch is open. Some equipment is fitted with buzzer to make a warning sound if something is done incorrectly. Often, the loudness of the sound can be adjusted. This circuit shows how this is done. Some cars have a buzzer that makes a sound when the driver opens the door while the headlamps are switched on. The door of the car controls the switch for the buzzer, but the buzzer should only operate when the headlamps are on. The headlamps are connected in parallel, so they can be switched on and off together. The buzzer is part of the same branch of the parallel circuit, as shown in the diagram. Switch S1 controls the headlamps. Switch S2 is controlled by the door. When the door is open, the switch is closed, and when the door is closed, the switch is open. Current cannot flow to switch S2 unless switch S1 for the headlamps is closed. Equipment that uses 12V batteries include cars, trucks, and some boats. These batteries need to be recharged from time to time. Sometimes a battery voltage indicator is fitted, so the voltage of the battery can be measured. The circuit diagram shows how a switch can be used to display the battery voltage. A voltmeter is connected in parallel across the battery, and a switch is included in this branch of the parallel circuit. Sometimes a lamp with a low voltage rating is required in a circuit with a battery of higher voltage. For example, a 6V lamp can be operated using a 12V battery. Resistors are used to produce different voltages. If two resistors of equal resistance are connected in series with a battery, then the battery voltage will be shared equally across each resistor. A 6V lamp can then be safely connected in parallel with one of the resistors, as shown. The lamp will receive a 6V supply and work properly.
Believe in your potential.